logging, monitoring, understand how to monitor all cluster components. And this is also kind of related to monitoring applications. Now, in this context, monitoring, I'm only thinking about metrics. We'll look at other troubleshooting techniques later, but we looked at logging before. We're looking at metrics now, like CPU usage, whatever's, some sort of number that you're looking at that you can maybe graph over time, essentially, is what we're talking about. So in the Kubernetes control plane, every component, even the controller manager, kube proxy, API server, each of them have their own concept of what metrics are important to them, right? So they all do different things, and as such, they all have their own concept of metrics. And the structure of this system is that every one of them reports on their own metrics, and they expose it on on some port, not necessarily port 80, right? On some port, they will expose out their metrics on a /metrics endpoint, right? But that data is only live data. So the idea is that they're just reporting on the metrics as it is at this instant, and then they rely on other systems to aggregate that and collect it over time into like a time series. So that's the first thing back in mind. Every one of these has their own metrics, and they all expose it essentially the same way. And one way you can start to see this a little bit, for example, is let me copy and paste this and we can look at it. So API server itself is all about serving up an API. And what you can do is you can call kubectl with a get and then pass a raw, which basically says, hey, go to the endpoint and just make a raw API call on this endpoint. And if you call that, you will see it comes back with all sorts of data. Right. Oh, and one thing I didn't mention, by the way, the format of this data, they're all in a standard format called Prometheus. And we'll talk about that more later. But there's a format that's standard, and they all emit it the same way. And the idea then is ultimately we'll consume it using Prometheus. But either way, so that's an example of API server dumping out its metrics. Some other ones a little harder to get to, so let me copy and paste this one, and we'll look at this one for a second. Oh, and this one won't work because I have to get my node. Okay, hang on. Get nodes. Give me my nodes. Okay, let me paste this in. So this command, oops, didn't mean to paste it. It's just another raw command, and what I'm doing is I'm going to the node. There's an API on API server where I go to the node, and then I can make a proxy command, which will turn around and connect to the kubelet, right, running on a node, and you can get details about kubelet. So what I'm looking at here is if I go to nodes, if I paste in the actual node name, so if I run this, for example, I'm getting logs. Well, there's two. There's the raw endpoint itself, just so you know, which is metrics more about the actual kubelet itself, right? But then if you add a CA advisor, this is basically the container, right? And it reports on like its container information. In fact, all this stuff right here, if you look carefully at this is actually all the containers that are running on this node, right? And it's dumping out container information like the CPU usage, or memory usage of the containers themselves. Okay, so that's what you're seeing here. Okay. Okay. So here's another example of getting at. Copy and paste this one. So we know that this is kind of on the edge of core DNS is really not kind of part of the core control system or control plane, but it's certainly a very important part of our system, right? DNS. So what you can do here is these run as pods, right? And so there's a way of doing a port forward. So I'm basically saying, go to, and you can, by the way, you can give a deployment instead of an actual pod name here. And what this is going to do is going to pick one of the pods in that deployment. So it says, go to this deployment, find a pod in there. It happens to be in the kube namespace, subsystem namespace, and then forward port locally 990 to port 9153 on the core DNS. And I had to look at the docs on core DNS to figure out where its metrics were being emitted on, and it's on that port. And if I was then go to localhost 990, I should see now on metrics. Oh, why can't I type? These are the metrics that DNS is now spitting out. Okay, so all this is basically to illustrate that, again, the main point here is that every control plane element emits its own metrics, essentially in the same format, and that format's Prometheus. And there's a little bit of trickery to figure out how to get to them. Now, of course, for AWS, we can't directly interact with the control plane elements like Kube Scheduler, and well, anyway, we'll see how we can deal with this with AWS in a bit. Okay, so this is a little bit of a side note. Earlier, we installed something called Metric Server. It was an add-on, and for the longest time, I was getting confused between what Metric Server did and what these sort of built-in metrics are. And the answer is they're different, and they serve different purposes. And essentially what Metric Server is, it actually pulls its information, right? Think of it as an aggregator. It's actually keeping a limited set of time series. So so you got containers running, and we want to know things like CPU usage on it over time, right? So Metric Server is a very lightweight in-memory store, right, where it pulls the actual, in this case, it'll pull kubelet, right, to get the container information, and it collects CPU usage and memory usage for the containers themselves and aggregates them over time, or keeps a copy of them over time, right? And it's pretty much there. Its only real purpose there is there was an old feature called Heapster, I guess, and this replaces it, and it's used by some controllers, in particular the horizontal pod autoscaler, right? So the horizontal pod scaler is which decides, do I need more pods because maybe my load's high, right? It needs some source of data over time to make those decisions, and it gets its data aggregated in Metric Server. Again, this is completely different than the /metrics that we saw earlier. And in fact, it exposes its data on a different port. So what I'm going to do here is I'm going to run a pod, and we're going to look at the data as exposed by Metric Server, and then maybe the more raw data that's coming from kubelet, right? So let's just do this by example. So let me Control-C this. Let's look at what stress CPU does first, and then we'll run it later. I mean, it should be pretty obvious by the name, but okay. So there's a container called Polinux stress, or an image, right? And so I saw that in the docs, and so I used it and learned about it. And here I can basically say, once this container starts up, it's going to put stress by computing like the square root or something. It's going to put stress on the CPU as if it was going to load up one CPU's worth of like basically one thread just going straight on, and it'll put a load on my on my infrastructure, right? So that's what essentially what this does. So let's run it, and let's look at a couple things here real quick. So I'm going to go to Helm install dev stress CPU. Again, we're just looking at look at the raw sources of metrics here. We'll look at some other tools, in a bit. But Huddle get all. I should see it running. Okay, it's running. Okay, so the first thing I can do, let me see if I can copy and paste here. Right, so let me copy and paste this. Yep. Make sure it works first. Oh, there it is. Just took a while. Okay. Okay, so what I'm looking at here, let's look at the command again. So what this is calling a different endpoint. This is not a / metrics endpoint. This is like APIs metrics K8s, right? So this is really hitting the API server on some particular endpoint that not related to the / metrics we saw earlier, and I'm pointing to a pod, and then I'm getting out, sort of a pre-digested bit of metrics about this CPU, and I see CPU usage and memory usage. In fact, you can see this number is very big because I'm really cramming the CPU here, right? So this is basically the metric server. This is the data series that the horizontal pod autoscaler uses. It also happens to be the same data that might be getting ahead of myself, but there's a cube control top pod, right? So this is essentially the same data set that this command uses too. And again, this is not the raw metrics. This is sort of digested metrics. Okay. Let's run a different command. Oh, this is going to be harder to get to. Okay, let's see if I can get to it. Okay, so I did this earlier. History grep ca. So let's run this bang 2017. So what this is the command to do, basically it's hitting the node, and it's basically hitting the kubelets / metrics endpoint / CA advisor. This is more of a raw data, and if I'm lucky, this container, let's see if I can get to it, grep stress. If I'm lucky, this is not running on this no, I wasn't lucky. So this must be running on the other. Let's see if I can get this. Kubectl get nodes. So it must be running on the other node, which is, we'll give it a whirl since we have a minute. I just forgot which one I was doing. 51. So not the 51. 252.221. Okay, let's see if I can see. Right. So what this is basically the underlying raw data that kubelet has on, obviously it's a lot more undigested, but this is basically the raw data that's coming right out of the container engine, being exposed through kubelet on the / metrics endpoint, right? And this is the data, actually, just so you know, this is the data that's the source for the metrics command. So the metrics server command, which was that simple little output that we got, that's actually is secondary, and it's getting data from here. Okay, so I think that's it for metrics server, right? It's completely different, and it serves a different purpose. In their docs, they specifically mentioned that you not to think of metrics server as a source of like graphs and metrics data. It's really only there for the top command, which is a quick troubleshooter, as well as the horizontal pod autoscaler. Okay, so that's that. Now in terms of the metrics that we're going to be concerned about on the containers themselves, primarily there's two that you look at. One is CPU, and it's some average, right? And essentially, it's amount of CPUs. So like one is one CPU, right, and whatnot. And then memory is measured in bytes, and it's the amount of memory that's being used. And I guess it has a concept of sometimes memory is kind of temporarily allocated and it can be shrunk down. So this is trying to get after the idea of what they call the working set. It's basically the amount of memory that process or this container actually needs to continue. I mean, it always needs it. It won't shrink it any further, right? So what we can do is let's look at this stress thing, right? So I stressed this. Well, I think I ran the stress CPU just a minute ago, right? So if I do kube control top pod, you can see that I'm getting some data, right? Now I'm stressing the CPU, not the memory, right? So that's why there's not much memory being used, right? But I'm definitely using a lot. This number is big. Now this is in mils and thousands, 1,000ths, right? So this is close to one CPU. But it's measured in 1,000ths of a CPU. That's why it's 996, right? Then you can also run on the nodes. You can also see, right? The nodes, one is being used relatively little, right? Other one has got a much heavier load, right? Now there's a little bit overhead the node itself has, right? But most of this 1,000 is actually my pod that's running on there. Okay. What else? Oh, and then in terms of like looking at the numbers here, let's look at one more thing. See how this says it's using 50% of the CPU, and that makes sense because we're using T3 mediums, and those come with 2 CPUs, right? So I'm basically using just over half of the CPU because I told to use 1 CPU. And the whole node has. The whole node actually has only 2 CPUs. So that's what that's about. Okay, so that all jives. Okay, so we're going to do, just for completeness, I'm going to do the same kind of stress thing on memory. So let me shut this down. Helm, install, dev. And I'm going to pause the video while this terminates. It's still going to, let me see, kubectl get all. It's probably still terminating. I'm back. So I wanted to stress the memory. So okay, it's running, starting to run. Okay, it's running. So kube control top pods. Oh, yeah, it takes, just so you know, the metrics for this take, even though it's collecting metrics all the time in the slash metrics, this aggregated metrics doesn't come in there's like a polling cycle for it. And so you have to wait like maybe about 30 seconds before you start to see metrics. So of course I'm not going to get it. So I'm going to pause the video, wait 30 seconds, and then come back. I don't think I looked at the stress memory, so let me just look at the code for it real quick. I can't remember what I did or didn't do, so I'm going to go make sure that I did it. You can see here I'm basically looking to put 500 megs of RAM on it, right? So it's going to use one machine, try to just continuously get 500 megs worth of RAM in use. And in fact, I just ran, so if I run top pods, right, you can see that it's using one CPU heavily, but it's using that one CPU to actually use up close to 500 megs of RAM, right? So that's pretty much how you can tell. And of course, then if I'm look at top nodes, right? One has got, let's see what's going on here. CPU memory. Why aren't I seeing a difference in memory here? Yeah, okay, so here's one thing what we're starting to see here. One thing I noticed is that the memory usage with this tool for putting pressure on memory is not as consistent. I'm not sure what's going on here, but earlier we saw it 500, but right now it's only using 147 megs of memory. So either way, that's unfortunate. Okay, now it's creeping back up. Let's see if I look at my nodes now again. One of them should be, yeah, so this one's substantially higher. Not crazy higher, but this is the one that this is the node that's running on, right? And then in terms of amount of memory, if I remember right, we're using T3 mediums. They come with 4 gigs of RAM, right? So I'm only using 500 of it, but either way. Now, one thing I didn't get after here is the same data. We've been looking at the data using through, we've been sort of using a convenience tool, this top command, which runs through the metrics server, right? But one of the things when we added the container insights, it also, let me remind myself here, when I installed the AWS container insights, kube control get pods. Oh, okay, hang on. Get pods namespace Amazon Cloud Watch. So if you remember, there was the FluentD, which was the log collector, but there's actually an agent running on every node that directly interacts with the container engine to grab the container metrics, and then that's what this CloudWatch agent is doing. So it's taking that same data, basically the same thing that the metric server is doing, getting the raw data, and it's now storing that same data, however, in CloudWatch. So yeah, I guess I must have closed down console. So let's look to see if we can find our container log data, our metric data. CloudWatch. So before we're looking at logs, now we're going to look down here at resources. And you'll see, if you look at this, you'll notice that these are all names of containers, right? Now, there could be a lot of containers here. They have a nice new cute map view, which is handy because it gives you a visual if it loads. Oh, that's unfortunate, being slow. I'm ready to load it. Okay, I'm going to pause the video for 30 seconds and hope this thing comes up. I gave up on the map view and I just went back to list view, and then interesting enough, I got a message. The map view was throttled. So I don't know what that was about, but I'm going to get rid of that. Oh, man. Okay. Okay, so I'm just going to look under stress, and here's my stress memory, right? And you can now see some graphs, which are much easier to read than just the raw data, right? And let's see if I run it for the last hour. See if you can see more resolution. So, I don't know why it's spiking down, but remember I told you this memory utilization was not as always stable. But either way, so what I'm looking at here is I'm looking at my pod, right? And then I'm looking at essentially the total amount of memory, CPU used by it, right? And the total amount of memory being used by it. And so this is peaking around 50%, which is what we're expecting. Again, this is not measured in absolute numbers. It's being showing in percentage of the node, which I actually thought that was a little strange. But so this is using 50% of the node, and then this is using about 12% of the node's RAM. There may be a way of changing the metrics here from percentages to. I just have no idea how to do it. So either way, the point is that this message. The point is that this this is basically this metrics agent that's running on each of the nodes is taking that container data and shoving it into CloudWatch, so then I can see these nice graphs, and then I can set alerts and whatnot in CloudWatch, monitoring my container applications. Okay, so what else? I'm going to leave this open. Get rid of that. Okay. Okay. So there's other tools. So we just looked at AWS's CloudWatch for getting after some of the graphs. Right now, if I go back to this, let me double check. So all the things under resources are just strictly pods, right? So these are just basically measuring containers, right? I'm not getting those other metrics that I'm interested in, like, I don't know, the core DNS or the whatever, right? Now, apparently underneath here, let's see. So there's some other data that's being collected here too that's separate, but I have not messed with this either. But this looks to be you know, again, this looks like still just node. I'm not seeing like all those DNS entries and stuff, right? EKS services, right? So, I mean, I think everything that I'm seeing in CloudWatch is mostly focused on CPU, memory, sort of some those kind of metrics about the containers themselves, maybe summarized in certain ways. But I'm not seeing like the specific metrics under /metrics. And we'll get to that where we can see that. So we'll come back to that in a minute. Before we do that, though, one thing I wanted to get after. So I'm done now with just Amazon's tool, right? And we're going to look at other tools that visualize that metrics data. And one of which is, there's a thing called, and I haven't been using this, there's a dashboard called the Web UI dashboard, which provides sort of a quick look at your Kubernetes cluster, including some metrics data that seems to be usable, actually. There's instructions on installing it. So there's instructions on how to install it. So I'm not going to cover that now, right? You just can do that on your own. But I'm going to show you how to use it. So before you use it, you have to actually create this user. And I did that exercise already. But you have to get a token out of this. So let's see. Getting the token. I think you have to copy and paste this. Because then when we do this, we'll need a token. So let me paste this. Okay, so I've got a token here. Okay, I'm going to copy this token because I'm going to need it in a minute. Because this dashboard's authenticated or authorized, right? You have to authenticate and authorize to it. So you have to create a user, the service account and then use a token from it. So now to get actual access to the you have to run this proxy command. So you go kube control proxy, right? And then you have to go to, I might just have to copy and paste this and go to your browser, go to this. It should ask you for a token, which means I need to copy this again because I copied the wrong thing. Copy, go to my dashboard, token, enter token, paste it. Hey, there we are. So this is now, so what we did by running that proxy, this web page is actually hitting our API server first, then it's being sent over to the dashboard service itself, which is serving up all these graphs and whatnot, all the UI. Okay, so in here you can also look at, for example, let's see if I can figure it out. If I look at my workloads under pods, right? There's it's nice because it tells you by namespace too, right? So I can change namespaces. So in the default namespace, I only have my pod, and you can see that I'm running basically one CPU, and you can see that now you can kind of see this visualization that the memory is kind of fluctuating. This thing is not stably using 500 megs all the time, so it's using memory over time. So of all the UIs I've seen so far, this one's by actually the easiest to understand what's going on. And again, I'm not sure how many people actually use it, but it's definitely available. It's super easy to install. It gives you more information too than just metrics, right? There's also like errors, and it gives you all sorts of data. You could actually do some commands from here too, some like operator kind of commands too. Okay, enough on the dashboard. I'm going to stop that. One thing I did though notice is that the dashboard didn't get me access to a lot of that raw metrics data I was interested in, and so the question is, where's that at? I think I'm done with this too. So that's where we come to the last tool. I believe this is the last section, right? And that's Prometheus. So whenever you talk about metrics in Kubernetes, it seems like Prometheus pops up, and it's an open source system. And there's a complicated diagram here, which I'm not sure if I fully understand, but basically you install it into your cluster, and it has a process that runs on your cluster, right? Like as daemon sets, and they, just like Amazon, they collect data and then they send it over to some backend data, and then there's instructions on installing it. Let's see if I can find it here. So it basically has the same basic pattern that we saw for Amazon, right? There's a daemon that collects the data and sends it off to something else. Now in this case, let's see, Prometheus. Well, I don't have a link in here. I'm going to have to go. Maybe it's here. Yeah, this is the Amazon document. So it's control plane metrics with Prometheus is the Amazon document, right? And basically, this just reminds you that there's raw metrics available for like the API servers here, but it's kind of unreadable. And so then you can install this Prometheus thing, and you can get after some of that raw data, right? So I'm not going to install this for you, right? I mean, on the screen, but you basically install it like here. And what do? You have to do a proxy thing too. Let me look to see. Once I run it, let's see if I can do this. I had a side note I wanted to do. So I want to be done with this proxy. That was for dashboard. Now I'm doing a port forward here, 9090. So if I go so what this is doing is saying, connect up to the Prometheus server, right? And which is running on port 80 apparently, but then expose it on my machine as port 9090. So now if I go to localhost 9090, right, you get the sort of UI like this, which is a lot less friendly because I didn't know where to go. And if you click on this, you will notice you get all this huge list of what look to be some sort of metrics. And if you look carefully at this is actually basically kind of a dump of that / metrics for different services. Like there you'll see like Prometheus itself reports on itself, but you'll see things like, where's DNS? Let's see. Kubelet, there's kubelets reporting. Then there's etc. That's the etc. database is reporting. Core DNS is reporting. Right. The containers themselves have reporting. In fact, you can actually get at the containers. If I go to container memory, where is it? Container CPU, no. Memory usage bytes, for example, and I say execute, then it gives you this sort of a kind of a very raw looking version of this. And then there's a graph too here. So let me go to graph. So you get these graphs, right? But the problem is you have this graphing basically every pod. And so what I'm looking for is stress. Let's see if I can find it. I think that's the one I want. See if I can find it. No, that was an earlier version of stress. Oh, so this is not the easiest to use, but let's see, because this keeps track of the historical ones. So let me try the second one. I'm going to try one more, and then I'm going to give up. Of course, it's not that one either. Okay, how many stresses do I have here? Oh, I've got 24 versions of stress. Oof. Oh, I'm not going to try to find it right now. I should have named the pod something different. Then I would have been able to easily find it. But again, this is kind of a more raw tool for, in fact, I'm struggling to even use it here. There we go. But you get access to, in addition to the containers details, right? And you get a lot more details here too, right? This is, in addition to the container details, you get actually after all those other metrics, API server metrics, whatever this API, I don't even know what this is. Whatever this is, step emission, blah, blah, blah. So the point is that if you want to measure metrics, this is definitely the top tier in terms of getting after all the metrics of your system. Now there was a side note I wanted to cover, and I've already lost my article. Actually, let's see, it's here. There was one side note I bumped into that I thought was worth looking after. And this is specific to EKS. So anyway, this is about Prometheus. When I went to go install Prometheus the first time, I was only running one node. And I noticed the pods would never come up. And I was troubleshooting that. And then it turns out I learned that EKS actually has built into their cluster, right, constraints about the number of pods that can run on a single node based on their class. So if you know anything about Amazon, they have all these different classes of systems, right? And of course you pay more for the more expensive classes. And we're using a T3 medium. So if I run T3 medium, you'll notice that T3 medium can only run 17 pods per node, right? Which I found a little surprising because I wasn't, a lot of these pods are not using a ton of memory, but they must have their arguments for putting these constraints on there. So, and then with 17 pods, I ran out of space. I have so many, if you look at kube control get pods, all namespaces, right? There's actually quite a few of them now running. Doesn't look like there's that many, but there's probably 20 something of them. And what was happening was when I was only running the system with a single node, I couldn't get, the Prometheus ones wouldn't come up. So then I had to spin up my second node, and then I can get all of my pods up and running. Okay, I think that is kind of a rambling, but what do we talk about? Just a summary. We first talked about just where the metrics, the raw metrics are, kind of how they're exposed on each service, right? Then we kind of got sidetracked on metric server, and it's completely unrelated in the sense that it's a separate service that collects data from kubelets metrics, right? And aggregate and keeps a history of them, and it's only really being used for horizontal pod scaler and the top command, right? And then we have to consider other solutions for kind of keeping long-term metrics on pods, right? And mostly interested in CPU and memory. So we looked at dashboard as one potential solution. We looked at, actually before that, we actually looked at AWS Container Insights and were able to see that data. And then we kind of saw kind of a light touch on Prometheus and how to get after the container metrics, but we also were able to see finally all the full set of metrics from all the services, and so that we can really report on how our, if you want some fine-tuned metrics that how your API server is operating. Okay, that's it for this video.